Hello and welcome, it's Dr. Red Frizzle here, and today I'm going to talk to you a little bit about diffusion and how it works. Okay, so diffusion. So first of all, what is diffusion? Well, diffusion is the movement of particles from an area of high concentration to low concentration, which basically means a movement of particles from where there's a lot of them to where there's not very much. Okay, so we usually think of this as diffusion of gases. So say you have a deodorant can. For the purpose of this video, I'll call it Lynx deodorant. Right, anyway, so there's the end here, little nozzle, sprays out a load of gas in the form of particles. So these particles are here. Now you might have seen on here, it might say high pressure or something, or flammable, and basically all this means, like with high pressure, is that there's basically a lot of molecules squeezed into a small amount of space. So when this is sprayed, all these molecules that are tightly compacted will spread out. And the reason why that is because the molecules in here, so isn't there like this, the reason why they can't actually move about much is because they'll just crash into the side. So so there's a high concentration of particles here. There's loads and loads of them, and once they're sprayed out, what will happen next is these particles will diffuse through the air. Now, this whole idea of diffusing through the air is just essentially moving through the air, because the air is such a massive space. These particles will, over time, just gradually spread out. Now, each one of these particles has its own kinetic energy, which is basically movement energy, so that they'll all be going in probably the same direction. But supposing this one, for example, crashes into this one up here or this one, then what will happen is that will force this one to change direction and move in this direction, and this one to move in this direction. So eventually they'll just generally spread out. Now, the example I've used here isn't actually diffusion in terms of like the actual spraying process of the gas. That's something else, because you're actually putting energy into pressing the button to spray it and encouraging all these compact molecules to spread out. But the actual diffusion takes place once these molecules have sort of spread out like this. Once they've actually sort of started to spread out, they'll continue to spread out, and this whole idea of diffusion of gases through the air is this idea of diffusion through the air, which is where molecules spread out and move from an area of high concentration to low concentration, because obviously these molecules being here that I've drawn, all this space around here is an area of low concentration, so they'll want to go into this area of low concentration. By want to go, I actually mean there'll be a net overall movement of particles there. Now, net overall just means that on average there will end up being more particles over here than here. So for example, because we've got such a sort of compact, well, they're not overly compact here, but they're relatively compact, what they'll do is they'll gradually spread out, and as they spread out, there'll be less and less particle collisions, and they'll spread out less and less. So once they're sort of spread out in the air currents will sort of take them around, and they'll end up getting much more spread out. But over time they'll actually diffuse less, because here they're going to diffuse a lot, because there's going to be a lot of collisions with these particles, because they're actually moving faster, because they've just been sprayed. Obviously the air resistance as these particles move will gradually slow them down, so there'll be sort of less energy, and especially once they've collided with other ones, there'll be less energy to encourage further diffusion. Although it will continue to take place, it will start off faster, and then it will sort of tail off, and it will happen a lot slower after that. Okay, so that's sort of one example of diffusion. Now you might be sort of familiar with the idea of diffusions across a semi-permeable, across a partially permeable membrane, sorry, of water as well. So if I draw you a partially permeable membrane, it's partially permeable just means that it's basically got gaps in which enables molecules to diffuse through. So let's just draw ourselves some water molecules. Water being H2O, so there's your two H's and there's your O. Right, okay, so these water molecules, I've drawn this diagram quite badly, so I'm going to have to actually label it. So the width for this water molecule I'm going to call 10 micrometers for the sake of this video. The width of a water molecule is not 10 micrometers. You can work out quite easily if you look at the radius of the individual atoms involved, like hydrogen and oxygen, if you're really interested in that. I've just sort of labelled it 10 micrometers for the purpose of this video, because I wanted to show you that that has to be smaller than the gap, because obviously it won't get through if it's bigger than the gap, and that's what it looks like from this diagram, which is why it's badly drawn. So this gap I've labelled 20 micrometers, so you know that the 20 micrometers is going to be a lot longer than 10, so it can actually diffuse through these gaps. Okay, so if there's a lot here, and there's not very much over here, what the laws of diffusion state is that these water molecules over time will end up over here. Now supposing there's equal concentrations on both sides, so I'll draw you another one. Supposing after a while these water molecules, I'll just draw you 4 squiggles to sort of save time. If you end up with 2 over here, so these have actually sort of moved over to this side, so that these aren't there anymore. You've got 2 on each side. Now this is known as isotonic. Isotonic meaning that there's the same amount of attraction for a molecule to be on this side or this side. So basically both sides across this partially permeable membrane are equal. So the process that's just happened is known as osmosis, which is a particular type of diffusion that we refer to when we refer to water molecules. That's the process of diffusion by water molecules, is osmosis. Okay? So I'll discuss the group isotonic. So there's also hyper and hypotonic. So if we have another diagram the same, supposing we've got some impurities now, supposing we've got, draw you a few solutes, I'll label these, and these solutes are too big to actually get through this partially permeable membrane. But you have lots of little dots, and these little dots are still our water molecules, or H2O. So basically, supposing there's 80% water here and 20% solutes, 80% water, 20% solutes, and over here there's 30% solutes, which have just basically dissolved substances like sodium chloride ions, they could be, sodium or chloride ions, and over here you could have 70% water. Now, in terms of diffusion and osmosis, the laws of osmosis state that, as we discussed before, that water will move from a high concentration, because it's the same as a particle, move from a high concentration to a low concentration. It's the same principle as these particles diffusing out. Okay, so it will overall move from here to here in order to make these concentrations balance. So overall, you'd expect there to be ending up being 75% water on both sides, because it's halfway in between this 80 and this 70%. So you expect them to evenly distribute themselves on either side of this partially permeable membrane. Okay, so what do we call this side of this partially permeable membrane? Because at the moment it's got a lower water potential, which means it's actually pulling the water. So excuse me, it's actually pulling the water because it's got a lower water potential. Because this is lower, which means the water actually wants to come over to this side. So this side, because it's pulling it, is known as hypertonic. Now, because this side isn't pulling this side as much, it's known as hypotonic. Now, the reason why I'm saying not as much is because both sides are essentially pulling molecules over to their side, because molecules will gradually, over time, diffuse either way. Okay? But because this is lower concentration and this is higher, overall the net movement will go onto this side, so this side has essentially got a greater pull. It doesn't mean to say that the molecules will, all the molecules will diffuse over this way, because you're obviously going to have, because I've said 70% water, there's obviously a load of water molecules here, and some of them will diffuse over here, but for every like, what is it, for every 7 molecules of water that will diffuse over this way, 8 molecules of water might diffuse over this way. So overall, extra water molecules are moving over to this right-hand side than left-hand side. And this whole idea of hypertonic means greater pull. So this right-hand side has a greater pull for the water molecules, so it drags more water molecules over to that particular side. So I hope that clears up a few sort of doubts that you may have had about diffusion and osmosis, and hope you understand that better now. So I'll see you in the next video. Goodbye.